Hi everyone, welcome to lesson 4.4, where we're going to talk about one more method of solving quadratic equations, and that's the quadratic formula. So using the quadratic formula, it's just another way to solve quadratic equations, and the formula is based on a quadratic equation being in standard form. So let's take a quick look. In standard form, you would have ax squared plus bx plus z, and you'd be able to determine what the coefficient of the x squared term is, the coefficient of the x term, and the constant. Once you have your quadratic equation in standard form, then we take a look at the equation itself, and x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2 times a. So let's just take a look at how we substitute. So if I have 2x squared minus 5x plus 3 equals 0, then I can identify here that the a is 2, the b is negative 5, and the c is 3. Once we have that, you want to make sure that you use brackets with your substitution. That helps keep track of the negative signs, and hopefully you don't inadvertently forget one. So we subbed in the a and the b and the c, these values here, into the quadratic. And once we do that, we zoom in and we just use our order of operations. Remember BEDMAS. So there we go, and we'll start with the simplification of this. So x equals negative 5 is going to give me a positive 5, plus or minus the square root of negative 5 squared is 25. Then we have negative 4 times 2 times 3 is 24, so we have minus 24 all over 2 times 2 is 4. So sticking with this, x is equal to 5 plus or minus the square root of 25 minus 24 is 1 over 4. And then we can split this up. Well, let's simplify one more step. So 5 plus or minus square root of 1 is 1 over 4. And now we can split it up. And we'll take x is equal to 5 plus 1 over 4. So x is equal to 6 over 4. And x is equal to 3 over 2. So that's one solution. And we could also take x is equal to 5 minus 1 over 4. So that's equal to 4 over 4. And so simplifying x is equal to 1. And that's the second solution. So the quadratic equation can be a little cumbersome, but it always works. So let's take a look at a different example on the next page. So here we go. B x squared minus 6x plus 5 equals 0. Let's identify what a, b, and c are. So our a is equal to 1, and our b is equal to negative 6, and our c is equal to 5. So let's go ahead and substitute. We'll use our brackets into the quadratic formula. So x is equal to negative b, and b is negative 6, plus or minus the square root of b, which is negative 6 squared, minus 4 times a, which is 1, and c, which is 5. All divided by 2 times a, which is 1. So x is equal to 6 plus or minus, we have negative 6 squared is 36, and then negative 4 times 1 times 5 is minus 20, all over 2. I'm going to move over. So I have x is equal to 6 plus or minus the square root of 16 over 2. x is equal to 6 plus or minus 4 over 2. And we can split it up here. We can take x is equal to 6 plus 4 over 2, which means x is equal to 10 over 2, and we simplify it, x equals 5. And then we could also do x is equal to 6 minus 4 over 2. That simplifies to x equals 2 over 2, and x equals 1. So there are the two solutions using the quadratic formula there. All right, let's take a look at a application. So we have the number y of northern Rocky Mountain wolf breeding pairs. X years since 1990 can be modeled by the given function. So when were there about 35 breeding pairs? So let's go ahead and we'll start with the function. So we have y equals 0.02 x squared plus 1.8x plus 3. And we want to know when there were 35 breeding pairs. So we'll set y equal to 35 and rewrite 0.02 x squared plus 1.8x plus 3. And of course, to solve a quadratic, we have to make one side equal 0. So let's go ahead and move that 35 over. Don't forget to change the sign. So we'll have 0 equals 0.02 x squared plus 1.8x minus 32. Now we can see what our a and our b is. They're decimals. Now the quadratic formula will always work, but why don't we see if we can change all of these decimals to whole numbers so it might be a little easier for us. If we go through and we divide everything by the coefficient on the x squared, which is 0.02, then we can simplify and get whole numbers. So 0 divided by 0.02 is still going to be 0. 0.02x squared divided by 0.02 is just going to leave me with x squared. Next, we have 1.8 divided by 0.02. We'll end up with 90x. And then finally, if we have negative 32 divided by 0.02, we will get 1,600. Now we have completely different A's, B's, and C's, and I think they will be easier to work with them. So here we have A is equal to 1, B is equal to 90, and C is equal to negative 1,600. We use our quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we substitute our values for a, b, and c. So x is equal to negative, b is 90, plus or minus the square root of 90 squared minus 4 times a, which is 1, and c, which is negative 1,600. All divided by 2 times 1. We keep simplifying. We have negative 90 plus or minus the square root of 8,100 plus 6,400 all over 2. Keep moving on from here. X is equal to negative 90 plus or minus the square root of 145,000 divided by 2. So we're looking for the number of years since 1990. I'm going to go ahead and evaluate. I'll probably get a decimal answer, but I'm going to round it to whole numbers because years can only be in whole numbers. So x equals negative 90 plus or minus the square root of 145,000 is 120 rounded divided by 2. And right here, we can also go ahead and just, sorry, I missed a 0 there. This is 90. Negative 90 plus or minus 120 divided by 2. These are all even numbers, so I'm going to go ahead and reduce all of them so that x is going to be equal to negative 45 plus or minus 60. So in one case, x can equal negative 45 minus 60, in which case x is equal to negative 105. And in our other case, x is equal to negative 45 plus 60. And in that case, x is equal to 15. Now, if we go back to the question, we're looking for x years since 1990. So the only answer here that makes sense is 15 years, because we can't have negative 105 years. So 15 years from 1990, there were 35 breeding pairs. So what year is that? Basically, we go back to 1990 and we add the 15 years. And so there were 35 breeding pairs in 2005. And we can write our sentence. Therefore, there were 35 breeding pairs in 2005. Great. So what you can do, and what I encourage you to do, is you can get onto Desmos or another graphing tool and graph the equation that we were just solving, y equals 0.02x squared plus 1.8x plus 3, and graph y equals 35, because that's how many breeding pairs there are, and see if you can find the points of intersection between the linear and the quadratic function. Once you do that, go ahead and get an image of it, whether you want to export the image and drop it into this document, or don't think you can hand draw it, so I would definitely use some kind of graphing tool. And just check to see, does the answers that we got coincide with the graphical system that you can see on Desmos? All right, let's move on to something called the discriminant. The expression under the square root in the quadratic formula, this bx minus 4ac, that's what's under the square root sign. This is called the discriminant. Now, what we use the discriminant for is to determine the types of solutions, x-intercepts, that a quadratic equation has. You take a look at our 3 different examples. We can have a parabola that doesn't touch the x-axis at all. In this situation, there are no real roots. You will see that when we find that b squared minus 4ac is less than 0, or if it's a negative. So if the discriminant is a negative, you have no real roots. Then you have a situation where the parabola can touch the x-axis just at one spot. This is a situation where the discriminant equals 0. So when the discriminant equals 0, you have 1 real root. Let's put that 1 real root, or real solution. Then finally, if we have b squared minus 4ac is greater than 0, then there are 2 real roots. And you can see that this kind of situation would result in the parabola crossing the x-axis twice. Right? So touching the x-axis once, crossing the x-axis twice, and then the first situation is not touching the x-axis at all. So we use the discriminant to describe the roots, but we can't tell exactly what the roots are without using the quadratic formula. But let's just practice a couple of these. Determine the number of real solutions of the following quadratic functions using the discriminant. So we still have to have our quadratic equation in standard form, and we still need to list what the b is, what the a is, and what the c is. So for this first example, a is equal to 1, b is equal to 8, and c is equal to -3. So if I put in the discriminant, which is b squared minus 4ac, the discriminant is going to be equal to 8 squared minus 4. The a is 1 and the c is -3. So we have 64 plus 12, and we have 76. So the discriminant here is 76. Doesn't necessarily matter that it's 76, but what matters is that it's positive. Since the discriminant is positive, then there are 2 real solutions or roots to this quadratic. Let's try a different one. For b, hopefully we notice that this is not in standard form, and so we have to do a little manipulation here. Let's go ahead and move 6x over to the other side. So we have all our terms on one side. That'll give us 9x squared minus 6x plus 1 equals 0. Now we can see that a is equal to 9, b is equal to -6, and c is equal to 1. The discriminant then is equal to b squared minus 4ac, and now I'll go ahead and do my substitution. B squared, well, b is -6. Make sure you have your brackets, minus 4 times a, which is 9, times c, which is 1. Let's go ahead and simplify. -6 squared is 36, minus 4 times 9 is 32. No, 36. Sorry. And the discriminant here is equal to 0. So once we know that the discriminant here is equal to 0, then we can say that there is 1 solution. So this is a situation where we would have a parabola that only touches the x-axis at one point. So if d is positive, we have 2 solutions. If d is 0, we have 1 solution. So let's take a look at example C, where we look at the quadratic equation. It seems to already be in standard form. So let's go ahead and list our coefficients. A is -1, b is equal to 4, and c is equal to -5. Using the discriminant, we have d is equal to b squared minus 4ac, and we'll sub in our values. So b is 4, square that, minus 4 times a is -1, and c is -5. Simplifying, 4 squared is 16, and -4 times -1 times -5 is -20. So the discriminant here is equal to -4. So since it's negative, we have no real solutions. So on a graph, this would look like a parabola that doesn't touch the x-axis at all. One more example, D. Let's go ahead and put this into standard form. We'll bring the -1 over. So 6x squared plus 2x plus 1 equals 0. So in this case, our a is 6, our b is 2, and c is 1. Plug everything into the discriminant. D is equal to 2 squared minus 4 times a, which is 6, and c, which is 1. So the discriminant here is 4 minus 24. And the discriminant here ends up being -20. So again, since it's negative, this quadratic equation has no real solutions. All right, let's move on. So let's summarize a little bit. We have taken a look at 5 different methods of solving quadratic equations. So for any given equation, it could be more efficient to use one method instead of another. And here is a table of advantages and disadvantages of each of the methods that we've taken a look at. So let's zoom in here a little bit. So we've taken a look at graphing, and some of the advantages is that it always works to give approximate solutions. And if we have something like Desmos, we have to do it by hand. It's not going to be quick. But if we have a graphing tool, we can see quickly the number of solutions. But it is not always exact, as we've seen. Like, it's very difficult sometimes to zoom in on those points of intersection on the x-axis. So then we took a look at factoring. Factoring is always good to try first because it's the easiest way. It's really straightforward if the equation is factorable. But if the equation's not easily factorable, it gets complicated, and not all quadratic equations are factorable. We took a look at using square roots. This is really quick when you have no x term, no middle term, right? And you can't really use the solving by square roots if you do have an x term. So that's the advantage, and then it's the disadvantage. Then we worked on completing the square. That always works. Sometimes you do have difficult calculations. And again, that is why we took a look at working with radicals and square root signs. And then finally, we just, in this lesson, took a look at using the quadratic formula. And again, this one always works, and we can always find an exact solution, but other methods could be easier or less time-consuming. Remember, the quadratic formula is a very large formula, and it can take up a lot of space on your page. So let's just take a look at some examples here, and maybe you can help choose one of the methods that would be most beneficial here. So if I take a look at x squared minus 10x equals 1, if I solve it, I have to make one side equal to 0. So I'm going to go ahead, let me zoom in, and I'm going to move 1 over to the left side so that I have x squared minus 10x minus 1 equals 0. So let's think of all of the different methods we could use. If I look for factoring first, I don't think I can come up with any numbers that multiply to give me -1 and add to give me -10. So I think this is kind of up in the air. I would either use completing the square, or I could use the quadratic equation. But let's just go ahead and complete the square here. At least we get some practice with either one. So we start by grouping the first two terms, and then we take the coefficient of the middle term, which is -10. So I take -10, I divide it by 2, and then I square it, and that gives me 25. So what I do with that 25, I put it back into my quadratic, and I add 25, and I subtract 25. I still have the -1 out here inside the brackets, and it equals 0. Then you want to move that -25 out. There is no coefficient in front, so we don't have to worry about multiplying any extra multiplication. So we have x squared minus 10x plus 25 minus 25 minus 1 equals 0. Let's go and simplify the perfect square trinomial. So we have x minus 5 squared minus 26 equals 0. So I'm going to now go over some space over here. So we have x minus 5 squared minus 26 equals 0. I'm going to work on solving this. So it's isolate for x, and we're going to move this negative 26 over to the other side so that I'll have x minus 5 squared is equal to positive 26. I now have to take the square root of both sides to get rid of that squared. And I'll have x minus 5 is equal to plus or minus the square root of 26. I can't think of any perfect square numbers that 26 can be divided by, so we'll just leave that as a square root sign. But we do still have to solve for x. So we have to move that negative 5 over, which becomes positive. So x is going to be equal to 5 plus or minus the square root of 26. And those are our two solutions. So not too bad using completing the square method. Let's take a look at b. It is in standard form. It is 2x squared minus 13x minus 24 equals 0. And right away I have some bigger numbers. I don't necessarily want to use completing the square with this one. So why don't we go back and practice with our quadratic formula. So a is equal to 2, b is equal to negative 13, and c is equal to negative 24. Remember the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative 13 plus or minus the square root of negative 13 squared minus 4 times 2 times negative 24 all over 2 times 2. Let's keep going with our simplification. We have 13 plus or minus the square root of negative 13 squared is 169 plus negative 4 times 2 times negative 24 should give me 192. And all of that is going to be divided by 4. Simplifying again, I'll have x is equal to 13 plus or minus the square root of 361 over 4. And as it turns out, we can take the square root of 361, and it is 19. So x is going to be equal to 13 plus or minus 19 divided by 4. So my solutions would be x is equal to 13 plus 19 divided by 4, in which case we would get 8. Or x is going to be equal to 13 minus 19 divided by 4, in which case x is going to be equal to negative, it's a fraction, 3 over 2. So sometimes you'll be asked to use one method or the other, and sometimes you'll just be able to choose whatever one you're more familiar with and more comfortable with. So let's just show you one quick one at the end. If I get something like this, c, x squared plus 8x plus 12 equals 0, Hopefully we've done enough factoring that you can recognize that there are two numbers that multiply to give you 12 and add to give you 8, and they are 2 and 6. So once we know those two numbers, all we do is write this out in factored form. X plus 2 times x plus 6 equals 0. And then our product property, zero product property, x plus 2 equals 0. So x equals -2 is one solution. And then x plus 6 equals 0. And simplifying, x is equal to -6. So yes, factoring super easy once we can recognize it. So practice with all of those 5 methods and understand the advantages and the disadvantages of all of them. And that'll help you decide which one you want to use. All right, I'll see you next time.